Question 38, find all solutions to the equation in the interval 0 to 2 pi. Please make note that 2 pi is not included because they use the cool parenthesis at the end, right? So you cannot give me an answer of 2 pi even if it does show up on the graph, but 0 is definitely fair game. All right, so what are we going to do with this thing? It looks like we should do a substitution for sine 2x. So we look at our handy-dandy formula sheet for chapter 5, okay, and what can we substitute? There's only one thing to substitute for sine 2x. All right, that would be 2 sine x cosine x. Why is it doing that? That is going to really drive me nuts. Okay, what what is going on? Well, yeah, I mean, hey. Okay. You are? Okay. We did a substitution from our formula sheet. Okay. Is there anything you could pull out of both of those terms? 2 cosine x. I'm gonna have to restart this. Or do something here. This is not cool. Let's see here. So if I pull the 2 cosine x out, I get a 1 and a plus sine x. Okay. Okay, so we set each one of the factors equal to 0. All right. And I'm going to have to zoom in closer because I need more room. And so 2 cosine x equals 0. And 1 plus sine x equals 0. So now I need to solve those. What's the first one? Cosine x equals 0. Right, because if you divide by 2 on both sides, you still get 0. What about sine x on the other one? Negative 1. All right. All right, probably going to have to, because you're dividing by 2, right? All right, so, ooh, that's a bad looking circle. Let's try again. Okay, that's better. All right, now, where is the cosine, which is cosine an x or a y or a slope? It's an x value, right? X value. And it is 0. So if the x value is 0, what do you got? Nope, definitely not. Pi over 2, yes, that's one of the answers. And 3 pi over 2. Okay, now the other equation or the other factor gives me sine x equals negative 1. Is that an x value, a y value, or a slope? Sine, we don't know where the sine is. Y. Y value, because I want to. So if the y value is negative 1, it's at the bottom. What? Oh, we've already got 3 pi over 2. Yes. Glad they left enough room for us to do the other question. Okay. I know. Angry. I'm going to rip my shirt off and become green. Okay, if I push that to the other side and substitute for sine 2x, what would you put in there for sine 2x? 2 sine x cosine x, gee whiz, plus sine x. Yeah, we need to do something serious about this. This is, okay, it's like we got neon sign going on here. Ugh. What? Pun intended. What pun did I use? Okay, it was like a blinking neon sign.
Yeah, that's what I meant, like a neon sign.
Well, that's what it reminded me of, and it was annoying. Okay, what can you pull out of those two terms? Sine x. Sine x across my heart. Okay.
We have more room next time.
Okay.
There is no next time.
Yeah, next time. Well, hey, there will be next time for some of you. Okay, never mind.
Pirate.
Nope, definitely not there. Okay. All right, now that we've got it factored, we can set the two factors equal to 0. So we've got sine x equals 0. That's pretty nice and easy. We got that one already solved for. What about the other one? If we set that equal to 0, we end up finding out that cosine x equals negative 1/2. Yeah, I will definitely after this question is over. So, if the sine of x is 0, is that an x value, a y value, or a slope? That's a y value. And if the y value is 0, what kind of answers you got there? We got definitely pi. If you quote me 2 pi, you didn't pay attention to the restrictions. Remember, go back up here, right in here somewhere. Oops, come on. Right here, it says in the instructions you can't use 2 pi. Now I know that you're not wrong, but in this case you are, only because they restricted us from using 2 pi. So pi is one of those answers. What's the other one? What are you going to call that one, folks? 0. So we got those two answers. And then cosine x equals negative 1/2. Is cosine an x value, a y value, or a slope? It's an x value. And hey, that happens at negative 1/2. It happens 2 places on the circle. One there and one there. So what are the 2 additional answers we need? 2 pi over 3 is correct, but not the other one you just quoted. So for this one down here, we do have 2 pi over 3. But what's the other one? Well, if that's 2 pi over 3, and this is 3 pi over 3, what's this one? 4 pi over 3, you were correct when you said that? Never let that kid talk you out of it. You were right.
I said
Yes.
When it says sine x equals 0 and the pi is 0, is 0 just in the same place that 2 pi is?
Correct. But because it's bracketed on the 0 end, I include that. But I can't include 2 pi because it's not bracketed. You just like you were fixed, man. You were staring, man. I thought, ooh, what's going on? Okay, let me pause the video for angle identity for cosine 165. So if you need 165, then you need to double that to find the angle we're using. So what is 165 times 2? Oh my goodness. I might have to. Well, it'll happen after lunch because I got to keep moving here. 330. So we're doing the cosine of 330 over 2. Oh my goodness. Okay. Now 330 degrees. Wait a sec. Let's 165. Where is that on the circle? Where is 165 on the circle? Which quadrant?
2. 3.
Quadrant 2, right? Somewhere down there.
Yes.
Now, is the cosine positive or negative in that quadrant?
Negative.
So remember how on the formula sheet it has plus or minus? You have to choose which one it is. And that's all about based on where you think 165 is and whether you think the cosine or the sine is positive or negative. So I go to my formula sheet and I look for the half angle formula for cosine. And it would be the square root of 1 plus cosine 330. Why did I what? All over 2. Well, I do need 2, but I don't have time. I got to keep moving.
Is this all off the formula sheet?
Yep. I went to my formula sheet. I saw the half angle formula, and I'm writing it down. I just put the 330 in for the angle measurement. Some of you really need to pay attention because it won't go well if you don't. Now, what is the cosine of 330 degrees? We know that 330 degrees is down here in quadrant 4. And what is the cosine of that? Radical 3 over 2 is correct. All right? So this is the opposite of 1 plus radical 3 over 2 all over 2. Sorry. If you do this magic trick, you will get rid of them, yes. In other words, if you're going to get rid of the denominator of underneath that radical 3, you just multiply by 2 top and bottom. I don't know. Where have you been, man? You didn't? Whoa, you didn't notice it to now. That tells me a lot. Thank you. Okay. So 1 plus, oh, sorry, not 1. Why would I say 1? I'm multiplying by 2, aren't I? 2 plus radical 3 all over what? 4. Right?
I have a question.
The cosine of 330 is radical 3 over 2, but no, that is not equal to radical 3 over 2. Now, I do understand you could take the square root of 4 on the bottom, but you have 2 plus radical 3 inside of a radical. There's no way that's equal to radical 3. Yes.
Why does it become 4 on the bottom if you're multiplying like the denominators?
What's 2 times 2?
But isn't it 1/2?
You can multiply by 1/2. Let's watch that trick. All right, so let's see here. I got this, which 1 plus radical 3 over 2 times 1/2. And we have a 2 on the bottom times 1/2. Okay, so when you distribute the 1/2, let's say you distribute the 1/2 to the 1, what do you get? 1/2, okay, plus radical 3 over 4 under the radical. Now those are exactly the same answer. Now how do I know that? Because what's 2 divided by 4? 1/2. So if you separate the two fractions inside that radical, you can look at it like that. So your method isn't going to be wrong.
But is it multiple? No, like,
It is multiple choice, which is a good point. And let me listen to her question, and then I'll continue with yours.
why is the green 2? Since that's in the denominator, isn't that 1/2? The green one, not the one that you find.
Do you want to take this 2 and bring it out here in front and make it a 1/2 right here?
No, like,
Dividing
why
by
isn't
2
it-
is the same as multiplying by 1/2. Yes?
No, like, why isn't it 1/2? If it's in the denominator, like 1 over 2. Like, I guess.
I know exactly what you're saying. I don't have a lot of room up there. If I write it down, I'm probably going to erase it. But so inside this, we could say 1/2 times 1 plus radical 3 over 2. We could say it like that. Instead of division by 2, we could say multiplication by 1/2. That is another way we could say it. And now, back to Ms. Hand's point, which is correct, this is a multiple choice final exam. So you really, even if you know how to do the math, you've got to kind of figure out which one of the answer choices matches yours. Sometimes kids get caught up in the fact that they know how to do the math, they just don't know which answer to pick. So pay attention to, look at those things and say, okay, well, this one is the same as what I have. I mean, that's all you really need to do there, because I think a lot of you will be able to follow the formula. So I'm going to erase some of this just to give myself some room. Maybe I'm going to erase some of this. Yeah? I don't know.
Did anyone ever say positive?
I would say probably, yeah. When
I feel whenever I feel like equate Hans, I think of like Hans from Cosine.
I think from like Han Solo from Star Wars.
I haven't even watched the Star Wars.
Okay. Okay. Question 41. Rewrite with only sine and cosine. So since there is a linear sine x, that is giving me a clue. Now, cosine 2x is the one on the formula sheet that has 3 different possible choices of what you can substitute for it. But this is giving me a clue as to which one I should be choosing. If I want everything to be either sine x or cosine x, what should I replace it with? One that only has sine x in it, right? So let's replace it. 1 minus 2 sine squared x. Yes?
Wait, so how did you know to choose sine?
How did I didn't write sine over cosine. What do you mean?
Why did you choose to do all sines?
Because there's no way that I can substitute something for this. That is locked in place, ain't moving. Okay? Okay. Now, this actually answers the question. Now, if you're looking at the multiple choice answers, could it be written in a slightly different order? You know how we do the squared term first and the linear term and the constant term at the end? Well, sure, we could do that. But technically, this answers their question. This has all sines or all cosines in it. That's all. Okay, don't sit there and go, oh, how am I? Now, could we factor that? You know, maybe we could factor that. But I highly doubt we're going to waste the time to factor it. Okay? You can look at the formula sheet and tell me. Might as well look at it just as, what is it? Yeah, I have a review packet if you need one. Well, let me get that. What did it have down here? Oh, the formula sheet? I could post that online. Yeah, it has it in that form right there. They didn't even waste the time to do anything else with it, which is fine. Now, 42, I would not expect. Who's lost? Okay, I found it, yes. Okay. Question 42. I would not expect a cosine 3x. Remember, I purposely did not choose cosine 3x to put on your test because of the amount of algebra involved. Okay? Good exercise, but it's a lot of algebra. Now, there's only one thing to replace for sine 2x, and that's 2 sine x cosine x. Ugh. All right? Now, as far as the cosine 3x, remember that this would be cosine 2x plus 1x. Okay, this is... So it involves a lot because now you're going to go back to one of your other formulas, your sum formula, and you've got to go through the process of working out this in great detail. Right? The cosine function for a sum was cosine of the first cosine of the second. Whoops, got to follow my own formula sheet. Cosine of the second. The sign switches. Sine of the first, sine of the second. So that was cosine, cosine, sine, sine. With a switch in the middle. And then there's that minus sign in front of it. Right? So what does that minus sign do to the whole thing? Come on, what do you get when you multiply something by -1? You get the opposite, right? So that would be minus for the first term and positive for the second term. Now, what are you going to replace that with? What are you going to replace that with? Well, there's only one choice of what to replace this with. What is that? 2 sine x cosine x. I know, this is so freakishly weird. Come back to me. Okay, there. So, what do we think we should replace cosine 2x with? I think we should use the one. I think we should use the one that involves, well, that's not going to help, I don't think. This is just ugliness. Maybe. Okay, I think I got it. Cosine squared x minus sine squared x. Yeah, I definitely wouldn't expect this on the final. Times the cosine of x. Yeah, I wouldn't expect. I can guarantee you we're not putting this on the final. Okay, I told you. I mean, this involves a lot of algebra and substitutions. Now, what I do want you to see is that there's going to be some like terms that get combined together. What can you just verify? What is sine x times sine x? So in the end, in that last term, you see sine squared, right? Now, the reason I chose this in here for my substitution was because I knew that there would be something. I was hoping that we could see some sort of cosine squared plus sine squared show up. Because then I would be looking with the Pythagorean identity for the number 1 to show up. Okay? I'm probably going to, I think this, I mean, I can go back and add more to this video if you want me to, but I'd really like to, because I just don't think that this with the cosine 3x is going to be worth our time to continue. Let's go to the calculator section. So if I need to go back and add more into this, I can. Yeah. Stop being so mean.
I'm gonna kill you.
That's okay. Okay. That's the reason it got banned, man. I'm gonna be upset with you. Okay, now circumference is 2 times pi times what? You're making crap up now. All right, now circumference is 2 pi r. Arc length is a fraction of that. So how do we find it? Okay, so 2 pi times 16, right? All right, so what fraction? We've got 8 radians out of a total of how many radians? How many radians are in a circle, folks? 2 pi. Okay, now please make note of the fact that they did not give me 8 pi radians. By the way, that would be 4 trips around the circle. All right, they gave me 8 radians, which is different. That's more than 1 trip around the circle, but not much more. I hope so. Anything cancel out? So what do you get? 128? Okay. All right, so move on to the next one. This time they give me the arc length, 11. Okay. They do not give me theta. Okay, so we know it's theta over 2 pi times 2 pi times the radius, which is 14. Thank you for the note. If you're in radians, the answer is yes to your question, because you know, some people in the universe like to memorize a formula, S equals R theta. That's a great formula if you're in radians only. So if you like to convert everything to radians and then use that formula, okay, but folks, the reality is it's a circle. It's just the circumference and you take a fraction of that. So for instance, let's say it was something like, you know, 30 degrees. You would take 30 out of 360 times 2 pi r. It's just a fraction of the circle. Don't get hung up on formulas when you already know what the circumference of any circle is.
So it's like part of a whole.
Yeah, it's just part of her whole, that fraction of the circle times the circumference. Okay, what was your answer to the question, or do you have a different question?
So how did you do this one that
Actually, that's a great question because I didn't know. However, what kind of test are you taking? Multiple choice. So I would look at the multiple choice answers to see if that gave you any helpful hints. Okay? But what do we get for theta? Now that's 11 over 14 what? Degrees? Because that would be less than 1 degree. Or is this in radians? This is in radians. Now, if my answer had been in degrees, I would have had to have changed that, right? I would have had to set it up 11 equals theta over 360 times 2 times pi times 14. So I would have had to solve that equation. Sorry, that's a bad looking 14. Well, then they must have done it in radians. Okay? So just look at the answer choices to decide whether you think it's going to be radians or degrees. If the radius of the Earth is approximately 3,960 miles, what is the linear speed of a point on the equator in miles per hour? The radius of the Earth is approximately 3,960 miles, yes? Okay, so what is the... I'm going to drive it, nice. Okay, so... in one straight line. Okay, now... what's the circumference of the Earth at the, so using that radius? 2 pi times 3,960, okay? That's the number of miles it is around the Earth. And how many hours does it take for that trip to happen?
66 hours. Well, it depends on like.
Yeah, it depends like how you're traveling.
I got 66.
Okay, folks. All right. You're not actually doing this yourself. If we just pick a random point and followed it, isn't it 24 hours in one day to spin around? Oh, yes, that's right. So, you guys are cracking me up. All right, take the calculator. Take the circumference and divide by 24 hours, right? No, I didn't say that. Gee whiz. How many miles per hour are we talking about?
1,036.
How many miles per hour? Lots of them.
Yes. That's answer choice E. Lots. Okay. Okay, so any point on the Earth is traveling. In fact, you right now are traveling that speed. Okay? If anything stops, you and I are flying through that wall and we're done. Yep, you're right. Okay? With enough of us, we could probably break the wall. All right, now, a turntable rotates at 68 revolutions per minute. Okay? 68 revs per minute. What is its angular speed in radians per second? Oh, I'm going to need more room, aren't I? Yeah. Okay, so we can change this to seconds, right? 1 minute is equal to how many seconds? Okay, so we can do that. Okay, so that's going to get rid of, it's going to get rid of your minutes. So now we've got revolutions per second. Okay, but we want angular speed. So 1 revolution. Now, would you like to do this in radians or degrees? Oh yeah, it says radians. Good point. Thank you for pointing that out to me. It's actually easier if you do it in radians because we know there's 2 pi radians in every revolution. Okay. Yes, that is always true. Okay. There's 1 dictator and 2 pi radians in every revolution. Thank you. All right. I said 1 dictator and 2 pi radians in every revolution. All right, so 68 times 2 pi all over 60 is what you're dealing with. I don't know what 68 times 2 divided by 60 is. So 68 times 2 divided by 60. So 34 pi over 15. Now, I don't know. I mean, you might type that all out. Maybe it's 34 pi over 15, and you're actually going to get the decimal 7.12. Okay? 7.12, radians per second. Okay? So I don't know. You know, it's multiple choice, obviously, so you're going to be... we just reduced. Yeah. Use a calculator to evaluate the function. Okay, they want the secant of an angle. So you're not going to be able to type secant on your calculator. Secant goes with which trig function? So this is going to be the cosine. Now, please make sure it says right here we need our calculator to be in radians. So that's the first thing I would do is change my calculator to radian mode. Otherwise, I'm not going to get the right answer. And don't think we won't put the degree version of the same answer in there to trick kids. Yes, we're horrible people. That's true. Okay. Now, how are you going to alter 0.2933 to figure out what radian we need to put in there? 1 over that, right? So I'm not going to waste my time figuring out what decimal that is. I'm just going to type it like this. I know, I thought so too. I didn't know. It's either that or smash his finger. Negative 0.964.
Is there a way to cheat the system?
Cheat the system? Load. I got it in radian. I type cosine. Yep, I got a negative. Oh, that's it. All right, now question 6, which is underneath there, which is hard to read, is cosecant. So cosecant goes with sine. So we're going to do something very similar, 1 over 0.2353. So negative point what? Negative 0.895. That's good. Yes, sorry. Wait a second. Did I do that wrong? Oh, yeah, you're right. I did the reciprocal wrong. Good catch. Yep, she saved us. She saved us. Nice job. You know, we never asked you any questions like this on a test. That's interesting. Yeah, it could be that's not there. You're right. Thank you. 1 over cosine 2933. I like where your head is on this one. You know, if so 0.2933 radian wise is, yeah, that is so 0.2933, where is that in radians on the circle? Well, then that means we don't understand what a radian is. Okay? Do you know where pi radians is at? What's the decimal approximate for pi? 3.14. Okay. Okay. What about the top of the circle right there? We called it pi over 2, which is the decimal equivalent of approximately 1.57, right? So where in the heck is 0.2933? somewhere over there, right? It's in quadrant 1. Okay, now, cosine, is that the x, the y, or the slope? That's an x. What do we know about cosine in quadrant 1? It's positive. Remember when I got a negative answer for this? That should have... Now, the reason I didn't catch it is because I just wasn't thinking about that radian measure. You know, a lot of us think in degrees a lot faster than we do in radians. Okay? And I'm glad you caught that. But it should have been a positive answer, which I should have, seen that negative and went, something's not right. 1 divided by cosine 0.2933. 1.0, let's see, 1.045. Okay, that's better. Why is that larger than 1? I thought the values on the unit circle had to be less than 1. No. It is fake. No. What things on the unit circle are less than 1? Cosine, sine, tangent. Which things are less than 1? Cosine and sine. Definitely not tangent, because we know that we can have infinite slopes. Or close to, really, really big slopes. Or steep slopes, I should say. So cosines and sines can have a maximum of 1. But what is question 5 asking? A reciprocal. So if you took a smaller value than 1 and took its reciprocal, wouldn't you get a larger value than 1? So that makes sense. Okay, and this one would obviously be 1 over sine 0.2353, now that I'm actually doing it correctly. I'm glad you caught that. 1 over sine 0.2353. And we should get 4.289. Good catch, kid. I like that. Solve the right triangle for all missing sides and angles. Okay, this shouldn't be that hard because it's a right triangle, right? So are we going to use SOHCAHTOA, law of sines, law of cosines, and I guess you're going to lunch. Okay, back on question 42 from the no calculator portion. I know we stopped in the middle of that one because of the difficulty of the algebraic substitutions and how I had mentioned that this more than likely was not going to be on your final. I mean, I'll double check it, but there shouldn't be anything quite like this. Here's why. You'll notice that in mine, I substituted with the cosine 2x. There's 3 choices for what to substitute for cosine 2x. I worked out the algebra for the other 2 possibilities besides this one that I've done on screen, and I got different answers for all 3. So when you see, let's see here on the, when you see over here on the formula sheet on the right side of the screen, you see number 42. It's written sideways on that paper. You'll notice that the substitution that they did, let's see here, let me get a different writing tool. The substitution that they did here was, get rid of that. Come on, get that off screen. Okay, all right, there we go. You could see the substitution that they did was this one, 1 minus sine 2 sine squared x. Their answer that they got differs from mine. Now, I'm sure if you went about trying to figure out how to do more substitutions, you could kind of show that they were all equivalent. But I did, not only did I show in my video the other one, let's see, is it over here? No, this one. Not only did I show you a different one in this particular video, we can clear that off. But I worked out the algebra for the last one and with the 2 cosine squared minus 1, and I got a completely different answer. So there's no way we're going to be fighting this on a final exam. The important thing to note from this question is to think through the process. Now, could I have a sine 2x minus a cosine 2x? Sure. And then, because that's a lot easier. And I think I'll try to change this for in future years for this particular question. Anyway, thought I'd give my 2 cents on question 42 since it was bugging me.